Are we good?
Hello? Yeah, we're good.
Excellent. We're live.
We're
live.
Almost ready.
Okay. Okay, we don't have much time, and we got a lot of work to do, so let's get at it.
Yeah. So my name is Clement Escoffier. I'm working at Red Hat in the Vertx team. And this is Kirk.
Yeah, Kirk, Pepperdine, and I have a startup, jclarity.com, performance diagnostic engine. Come check us out.
So, and in this talk, we are going to see how we can integrate Vertx into an application and what are the benefits. But actually, integration in Vertx is completely changing how the architecture of the application works, because this talk could have been entitled A Path to Reactive. So to understand how we did the integration, how Kirk did the integration, we need to understand a little bit what means reactive and what is Vertx and how we can do that. So during this talk, there will be some live coding without any safety net. So if you help me, if you see some mistake, you can get one of the books that is there.
Polo, I get the leftovers.
Yeah,
so.
Polo, you don't play. Well.
So don't make any mistakes. Okay.
So the first thing is, what does reactive means? And well, I'm a former academic, and I'm getting old too, so I do this thing that nobody is doing anymore, is looking into a dictionary. I look at the reactive word in the dictionary, and if you open the Oxford Dictionary, you have the URL there. You will see that being reactive means showing a response to a stimulus. That's very vague, but actually we can apply this definition to a software and say that reactive software is an application reacting to stimuli such as events, inputs, failures. Well, the thing with this is that every software we ever built is somehow reactive, because it's in the nature of software to obey to the operating system, to the user input sometimes, and so on. So it's true, it's actually true, but recently reactive took a different meaning. It's really about being non-blocking, using streams of data, and being asynchronous. And when you start doing a reactive system or reactive application, you will have lots of events. And events are going to flow inside your system, distributed or local. And this is actually changing how we build your application. So typically, when you do an event-driven application, your application is not using too much imperative code as you were doing before. You will have a lot of constructs like on event X, do some stuff, and send event Y. And you will have a set of constructs like that. And this is this set of constructs that are going to build the behavior of your system. So it's very cool because it's introduced a loose coupling between all your components, because the only things that exchange are events. So you can change one, you can change the other one, so there is some kind of loose coupling here. But it's a shift. Traditionally, our software looks like that: synchronous blocking pool. I'm doing a REST app. I emit an HTTP request, get some response. This is I'm pulling the information. In an event-driven application, in a reactive application, everything is asynchronous. Everything sends events and receives events over a message backbone. Many implementations of it. We will cite a few of it. And it's completely non-blocking, and it enables push. And we are living in a world where push is the main way to interact. How many of you have notification every minute on their phone? Mails, Twitter, Facebook, whatever. So see, we are really living in a push world, and this type of architecture is made to handle such kind of things. So it's allows decoupling for different manner. The first one is because we send events to a virtual address, a name, topic, queue, and on the other side, we listen for events on this typical address. When we send the event, we don't know if someone is listening. If there is one or X people listening, we don't know, and we don't care. The main thing with this is that it also allows distributing. Because if you send, and if you have a distributed message backbone like Kafka, MQP, or the Vertx event bus, you don't care if your listeners are on the same machine. You just publish it, it will go across the network and be sent to the different nodes that are listening. Depending on your message backbone, it also enables temporal decoupling, in the sense that you can send event, but nobody is listening. But if you have durable messaging, then if someone starts later, it can just keep up and do the processing. So temporal decoupling is actually very interesting if you do microservices with rolling updates and stuff like that, because sometimes no one is there. Anyway, A little bit more about Vertx. Vertx is a toolkit. So basically, it's a library. You put it in your POM file, in your Gradle project, you're done. There's nothing else to do. It's a toolkit to build distributed and reactive systems. It has been designed for 5 years ago, or started 5 years ago, with reactive in mind. So that's not something that has been added as an afterthought. It's something that we had in mind since the beginning. Vertx is about freedom. So we don't give you the rules about how you will create your next pretty cool system. You do it as you want. So for this, we don't force you to use one specific application development model. You can use your own. In the demo we will do, we are going to use Java with callbacks. You could use Vertx Java, you could use Kotlin, you could use Scala, Ceylon, Groovy, Ruby, and so on. And depending on the language you will use, the construct that you will use to handle the asynchronous aspect is going to be a little bit different. If you use Kotlin, coroutines, they are amazing. If you use Scala, use features. They are better than any features that we have in the Java world, on pure Java world, and so on. The next point is when you build an asynchronous system, concurrency is key. Don't even think about using thread pool or one thread per event, because if you do one thread per event, you are going to run out of memory. And as this day, we are always deploying into a container. Kirk, bring one.
I brought a heavyweight container here.
Yeah. So if you reach out of memory in a container, something very cool happens. You're killed. That's cool, right? So you don't want to do that. You don't want to create so many threads and so on. So you need to think about another way to do that. And in Vertx, we took a very different approach. We say, hey, let's use a single thread and do everything with this single thread. That's what we call event loop.
That's a very novel idea, single thread.
Yeah, since the 60s, probably even before that. But yeah, well, we never say that we were smart. We just reuse stuff with class. So let's start with Vertx. Vertx.vertx. You create your Vertx instance. That's all you need to do. I'm going to do that live in a few minutes. Then you need verticals. Verticals are event-driven components. Here it's a Java class. Depending on the language you use, they can have different forms. And a vertical has a life cycle, start and stop. Both are optional. I only wrote it on stop, but actually start is also optional. And well, a vertical is going to listen for events, send events, and do such kind of things. And you deploy it with Vertx.deploy vertical. Each vertical is going to be assigned to an event loop, which is a thread. And an event loop is very simple. It does this. It has an event queue somewhere, and it do a spin. Get next event, find the event handler that is interested by this event, dispatch, next event, and so on. So that's pretty cool because it comes with one main benefit. You don't care about synchronization anymore because you cannot have concurrent access if you have a single thread, right? So no more synchronized, no more concurrent hash map, and so on, no more volatile. It's very simple and makes things a little bit easier. The only issue with that, it needs to be non-blocking. Because if you start blocking in one of the handlers, what will happen? Well, the publisher of event will still publish their events, and you will queue them until you run out of memory. So this is the Vertx golden rule, well, event loop golden rule. Never, ever think about blocking. Anyway, the majority of the Vertx team is French. So if you start blocking the event loop, we do on strike. And Vertx does a strike too. And we are very vocal when we do strikes, believe me. You don't want to see that. So we print stack trace and stuff like that.
Yeah. We've seen the unemployed go on strike in France.
Yeah, of course.
And they won.
Of course they won.
Okay.
One of the cool aspects of Vertx is every event loop will be attached to a CPU core, actually 2 event loops per CPU core because of hyper-threading, which means that if you have several verticals, the load is going to be dispatched on a set of cores out of the box. You don't have to think about it. It's going to be done that way. So you will use all the core you have in your machine and without having to do anything. Because it uses a low number of threads, memory usage is really very, very reasonable. Well, the event bus, because obviously we need a way to communicate, but this is better if we do that with some code, right?
Yes, absolutely.
So let's skip that and discuss a little bit about this and then show you some code. So the Vertx ecosystem is huge and thrilling. You can do microservices as everybody is doing microservices this day, circuit breaker, service discovery, and so on. You can integrate with different messaging protocol, MQP 1.0, Kafka. Because we are non-blocking, we are really good at network CNI. So HTTP, HTTP2, gRPC, service proxies, which are RPC on the event bus. And if you don't know what gRPC is, it's Corba 2018. But it's very similar to Corba. If you love Corba, you will love that one. I love Corba. I'm very sad that they removed it. We have a lot of primitives about ops, too. I have an ops background, so I want to sleep at night and have alerts and stuff like that. And we obviously have data access, so you can do almost anything. Integrating Vertx. So where did you integrate Vertx, Kirk?
Right, okay, so that's a great handover, right? Thank you. I'll try not to talk so fast. So we built this GCA analysis tool called Censum. I've been working on it for like longer than I can remember. And I kept basically throwing away the code base and restarting one. And finally, I ended up with this, what I call an event source model. And the reason why I went to event source was because it provided me some stability. In other words, the events remained stable. The parsers that I needed would change, the things that I wanted to do with the output would change. But the thing that remained stable over time was were the events. And that provided me some stability in the model. And so since it was event source from the beginning, when we went to actually distribute this out to say, okay, we want to run this on live systems across hundreds of JVMs and you know, really scale it out and have some fun, we looked at the event sourcing bus that I had in there, and we looked at it and it says, okay, this pretty much sucks, right? Okay, so what are we gonna use? So we went out and looking around, and as soon as we saw Vertx, we just said, this is a perfect fix. It really literally took us about 3 days of work to change our application from using our custom eventing things to actually writing things into verticals and then connecting the verticals together with the bus. And we got rid of some bugs and all kinds of other problems, and it gave us a really nice ability to actually scale out. So we use it at very wide scales right now. So that's the tooling that we're actually working with, right? So, you know, and it just does a simple thing, right? Basically, we take a log file, we read it in, we produce some processing on it, and aggregation, and we get some charts like this. And, you know, so simplified architecture, right? File reader, parser, reports. So we have this, I wrote a small version of this, and he's going to have some fun with it in a couple of minutes, yeah. So yeah, so we ripped the event bus out. We put in, used the Vertx bus. And the fun thing about this is that in Censum, I didn't have just one parser. And sometimes I don't have one parser running at a time, right? We have like 9 different parsers in there. And all of the parsers actually do anything. And it's not to get good saturation in the core. I really don't care about performance, which is like coming
from a performance guy.
For the performance guy. What it did was it gave me separation of concerns. And by getting separation of concerns, each of the individual parts became much simpler to write, maintain, to test. You know, basically, you know, when I needed some new bits, it was like spec. That's my container environment, send the spec out, I get a vertical back, we plug it in, it works. And so it's just a really, it's been very, very useful in that regard in describing like a deployment environment.
Time to see some code, right?
Yeah, I think so.
So I will let you introduce you to your own code, and then I'm going to, yeah,
okay.
That's your code.
Right, so this is the old sucky code. So what am I looking at here? So I think what we're looking at is a safe point view. So in this case, what I'm doing is I'm actually taking safe point data out of the log file. And can we just run it? Where's the run bit? Over.
Let me run it. Right click, run.
Oh, okay. Yes, of course. I was looking for the menu because yours is set up differently than mine. Okay, so basically, you know, it's just doing what you would expect to do. Let's put it out there where they can actually see it. What happened? Okay, doesn't matter. So it's just like, you know, a summary and some interesting tables to take a look at exactly what happened. And so this is just using like an internal bus that we've written. Where's our bus at?
Yeah, safe point event bus.
Yeah, safe point event bus model abstract. Yeah, I wrote this code, believe it or not. You know, so anyway, so you can see the events and stuff like that. So we the events just sort of like mostly become data holders, so they're just holding like representations of the log files and stuff like that. But if we look at the event bus, then essentially what we're doing is using like a custom bus to just sort of like, you know, subscribe to, and then just use the regular eventing model like so you can publish things. I think one of the more interesting things we did down here actually is, that's in testing, is to go into here and actually do something. So this is the interesting thing about it, right? So if you think of the traditional flow is that I'm always pulling. But if you want to go event model, then you actually need to be pushing, right? And so what we actually did in this particular case here is just basically said, okay, here's a bit of code. Where's the stream method? Right up here, right? It basically says, okay, here's my data source. And what it does is it turns it around, and all of a sudden, just from pulling the data out of the model, what this does is it actually pushes the data out, right? And so when you push the data out here, we can just wrap this in like in a vertical, like a little container. And when we wrap this thing into a little vertical container, all of a sudden, when we push out, we're publishing out on the Vertx bus. And then at that point, we don't really care. It's just like it's consumers of the data at the other end. They're going to consume the data, and they're going to do just whatever it is that they actually need to do to the data. And as you can see in this case here, the data provider in this case doesn't even care if it's zip, gzip, or regular file or anything. It doesn't. Or we have another adapter that adapts to live JVMs or whatever. So we just don't care. It's just like that's the data source. Just push it out onto the bus.
That's pretty cool because it's completely abstract the model we have behind it. So you pushed, and we will just transform this data and send that to our aggregators.
Right, exactly. And the aggregators are at the receiving end of all of this in terms of these are the things that actually will, you know, save point summary. So this is just like aggregating the data that we use to build the views from.
Yep.
Okay.
I would like to
and these are consumers, again, they're wrapped in a container that's providing a vertical, so we just like dump them in, the events come in, we process them.
So there's a couple of things that was weird about your event bus. Like there is this await termination scene that looks blocking to me.
It is.
Yeah, I don't like blocking.
Yes.
Blocking is not cool anymore. We like waiting anymore. We don't want to wait, we want things to come to us. So we are going to reshuffle a little bit your code and get it a little bit better shape.
Excellent.
So let's get to some other, yep. Okay, so we are going to delete this file later anyway, but I would like to start by what I've just shown here is that we need to create the Vertx instance. So I'm going to move the mic because I don't see my screen. Okay.
Here, I'll get that, don't worry. You don't need this mic, you have one on, right?
No, I don't have one.
Oh, you don't have one on, okay, so you do need this mic, okay, here we go.
Okay, I found the file.
I'll deal with it.
So, as I said earlier, okay, does it work? No.
Yeah?
I broke everything.
I got it, it's fine.
Screw it?
Yep, I got it.
Okay, yeah.
Yeah, it's.
Try not to touch it.
Yeah.
Don't touch it.
Do not touch the mic.
Okay.
Hold on, I gotta turn it back on.
Oh, okay. Doesn't matter, you can talk there and talk into here.
Okay, so the first thing I'm going to do is to create my Vertx instance.
So he's creating the Vertx instance, we're done.
So the only thing that has been done is adding the Vertx core dependency to my POM file. I'm using Maven. If you use Gradle, just add this dependency and you're done. You just need that, and then you have your Vertx instance. And on the Vertx instance, we are going to deploy vertical, but before that, we need to implement such kind of vertical. So we are going to see the data source vertical publisher, which is this one. So the first thing is we are going to get rid of this await completion because, yeah,
I
it
spent a
does
lot
nothing
of time
non-blocking.
writing that code, and
I see the original code, and that was.
Okay,
Yeah.
do it. Just do it.
So-
I'm not going to watch them.
But when I publish, so this method is called, and when we will trigger the event generation, and we need to publish all the items from our log file to the event bus. So I will get the data source, get the stream. We have seen this method. So I just get the stream, and for each entry, I'm going to send them on the Vertx event bus. You access the Vertx event bus using vertx.eventBus. You publish to an address, here, hotbox, and the item. So let me do that like this.
So I think at this point you can see the advantages of actually inverting the flow right from the source, right? So you set yourself up to do this.
There is one thing we need to do is when we reach the end of the file, it's always good to send us a termination event, say, hey, we are done. So I'm going to do that now. Same thing, I'm going to publish an individual event which will be datasource.eot, yeah. End of sequence token, which means that, end of stream token, which means that, well, we are done, and the rest of the system can listen for this and say, okay, we are done, we can do the cleanup, and so on. So that's all we need to do. We read the stream, publish. In the event bus, there is two methods, publish and send. Here we absolutely need and want publish. Publish, send to all the listener, send to only one, and does a round robin. And here is definitely not what we want. We really want to broadcast our items. So we need now to switch to our parser that will be in between. Publisher here. And again, it's a vertical. This code didn't change, and this is a Vertx bit. So we have the address in, the address out, okay. And when we get, when we get an item that we just sent, we need to process it. So in the start method of my vertical, I'm going to register a consumer on the event bus. Event bus.consumer. I'm going to do that in many steps that you understand. So my inbox, okay. So here I have a consumer. It's actually going to be a consumer of string, because it's what we send. The consumer must have a handler attached to it. It's a method that will be called for every event that we receive. So let's configure that. So
This is our async callback. Huh?
yes, I'm using callbacks here, and here I will just do call the process method. So I'm receiving a message, and a message is just a body and a set of headers. So we retrieve the body, which is here a string, we trim it, and we just send that to the parser. The beauty here is that I didn't have to change the parser code from Kirk. I just isolate it from the Vertx side and just inject my events directly. So I can reuse a lot of his code. One last thing. The Vertx event bus can be distributed. And one of the important bits of part of this distribution is that registering a listeners on the event bus can take time, because these listeners, this registration need to be propagated to all the nodes on Vertx. So it's not because you are here that you have done it. So it takes some time. So we need to register a second handler, which is a completion handler, which need to well, we tell us if we are done with the subscription. So it gets a parameter, which is an asynchronous result, because actually event registering a handler in the event bus can fail, so we need to check that.
Right, so this is when we start the vertical. We have to wait until the vertical's deployed. And that's important later on when we start everything up. We just want to make sure all the verticals are deployed before we start streaming the data through the system.
So,
and that's a lot of code. Can't you fix that?
Yeah, I'm up. Actually, here I need to fail, because or I'm in trouble.
Yeah.
But and here complete. But yeah, I agree. This is a lot of code, and I know that you love compact code. So let's do something a little bit more compact.
Yeah, I don't like writing code, so that's why he's doing it.
I got a feature here, which I use. It's a Vertx feature. It's not a Java feature. So it's totally non-blocking. A Java feature, a regular Java feature, you have this get method that blocks. It's awful. I don't like blocking. I don't like waiting. So the Vertx features, you don't have a get method. You just can attach a handler. In Vertx 4, we will also support completion stage. Completion stage, not completable feature. So the interface on top of that, which doesn't have the get method. So much better, and non-blocking. So I will take and we are done. Is that more compact for you?
Yeah,
Oh, actually,
it's getting better.
until J can just say this.
Yeah, that's better.
So basically, it does exactly what I was doing. So if it's a success, then complete and stuff like that. But I just pass the future, and when the completion handler is done, it will just make it. We also need to do something here. So once I have processed something in the parser, I want to send that to my aggregator. So I'm going to publish on my outbox.
Yeah, we want to just publish the events to the consumers.
The issue here is that this event is not something that the Vertx event bus can handle directly because it doesn't know how to serialize that. So we need to pass some delivery option that I have there that where is the option? Yeah, that just says the codec name that we have registered to use that. So I'm still a little bit puzzled about this part. Is that a bug or a feature? But something you need to understand is that when you send an event to the set of subscribers, even locally, you need to be sure that this event is immutable. Because if it's not immutable, imagine if the first subscriber starts modifying the object, then it's visible by the other subscriber too. And things can quickly get messed up.
Right, and if the components are distributed and you have one guy changing it, all of a sudden you have an inconsistent model across different virtual machines. So you need to be really careful. You get inconsistent behavior at that point.
Okay, the last bit we need to do is the aggregator. So now we are doing, so the parser is done, getting items, doing the parsing, and sending JVM events. So now we are in this part, which is also a vertical. And in this part, I just need to register a consumer to get those JVM events, and we will be done. So the rest of the code is unchanged. So let's do that. But I'm going to use something a bit more compact than the sequence I was using before. I will get the event bus, do a consumer on top of it. I listen on inbox. I will get a message using lambda here. Something, I've prepared a message method that does the work for me, and I will just register the completion handler and so on. Because I didn't say that it's a JVM event. Yeah.
There you go.
And we can even ask IntelliJ to make it better, and we go. Oh,
you can even take rid of that now.
yeah.
Hey,
Look what compact is this.
That's getting somewhat better.
So 3 lines. I get the event. I register a consumer on the inbox. For each event, I call this process method that will do the aggregation and all the smart things that you did. And that's all. I want to be sure that we have registered. And when we are registered, I say, OK, the vertical is deployed. Hey, we forgot to deploy the vertical. We need to do that.
Yeah,
So,
how do we wire this all up?
so it's actually quite simple. I will go back where I created my Vertx instance here. And I will create a sequence of asynchronous action, because every deployment of vertical is asynchronous. It can take time because we register something on the event bus. So we want to be sure that we don't register another vertical, don't deploy another vertical until the previous one has been completed, or at least the deployment. So I will start with a starting setup termination, which is listening for our termination event. But then, so this is returning a future. Again, Vertx future. On a Vertx future, I can use the compose method, which will just chain another future if the result of the previous one is a success. So here, I don't care about my thing, I can deploy the aggregator. So I have a method that does that.
Yeah, so we want to deploy the components in the reverse order that they're of the flow.
Aggregator first, parsers, and then we will start everything.
Yeah.
So this is basically how we deployed a vertical here. I have created the vertical here. So the aggregator set is a vertical. I have passed the address I want. I add the aggregator, so that does the fancy logic to understand the log file. And I deploy the vertical on Vertx. And here I just say when it's done. So then we need to do the same thing for the parser, and I will continue my chain. Deploy parser. There we go. And finally, we want to do the same thing for the event source, but we also want to start the event generation here. And I will do the same thing. Deploy and start event source Vertx. What do we want? The data publisher, okay, and the runnable. Yeah, that's because I do way too much functional programming at the moment. So everything is a function, and reduction is just loading the file and emitting the event. So that's what is done when this is when this is deployed. We can look at that. I deploy my vertical. If it failed, okay, it failed, and if it not failed, it complete and run or runnable.
Yeah, that's the ugly version of the code, right?
We can improve that, yeah, a little bit.
Yeah, but it's okay. It'll run.
Yeah, it will run, but I want to clean up a little bit your code too.
What?
Yeah,
I spent all this time writing code, and you're going to know.
Yeah, this event bus, I really don't like it, and I believe we definitely need to delete this.
Okay.
So I'm going to delete it.
I even had like Heinz trying to debug that for me.
So delete anyway. We'll do the old good manner. We try to build again and again until we have, this is, the safe view. Let's delete that too.
Okay.
Yeah, less code, that's good. Do refactor, build again. Your test, come on, who need test anyway?
You're getting rid of my test now?
Yeah, we don't care about your test.
Okay, so he's getting rid of my test here. I'll have to say one of the sticking points that we did run into that did take long. I mean, we had the product working, and we didn't do the test first. We came back and tried to retrofit the testing. And testing asynchronously was a bit of a challenge at first to figure out how to do it. That's probably another talk on its own.
Yeah, but the thing is, if you use JUnit, the thing is that as soon as the method, the JUnit test, and it considers that it's green and it passed. This is that in an asynchronous world, it reached the end of the method. That doesn't mean that the processing has happened yet.
Yeah.
So we need to say, hey, come on, wait a little bit until we have done our processing and we have tested everything.
Right, so we wrote a whole framework to manage that flow within JUnit so that we could just plug the tests in afterwards and keep on testing.
So in Vertx, we have Vertx unit for that. That does this. Provide all of this. And if you want to use JUnit 5, we also published an extension to do asynchronous testing with JUnit 5. And if you like JUnit 5, check it out. It's pretty cool.
Okay, we didn't use any of that stuff.
Yeah, you wanted to do your own, right?
Yeah, absolutely.
So, let's run it and let's see if it works. So the first thing I would like to show you here is that this is the JVM version. All the code we did works on Java 11. So it's Vert.x working on Java 11. And there is a few things here. Actually, you can pass flags to force Netty, because we use Netty under the hood, to not use such kind of things. But we have everything, right?
Yeah.
That's what you wanted.
Yeah, looks pretty good. Looks pretty good. There's only one problem, right? This is a desktop app. And no one wants desktop apps anymore.
It's cool. But
no one wants desktop apps, right? So they want to deploy in the web. So
I may have something for you, at least a minimal version of this.
Okay.
So let's close this and let's switch back to another branch.
We'll talk about the problem with web containers in a second.
Let's switch to master. So I have done exactly the same thing, but with a web view. So that's the same code. Compose. The only thing is that it starts a web view here, or at least a web server up here. So it starts a web server on the port 8080, and the only thing it does is get the events and forward them to my browser using sock.js. So you may never heard about sock.js, and it's one of these rare JavaScript libraries that are more than 6 years old and still works. It doesn't depend on left pad and so on, so it's pretty cool. And basically, it negotiates the protocol between your browsers and your server. So if you support WebSocket, it will use WebSocket or degrade relatively well. So SSC, and then I can't remember what is next. But even if you use Internet Explorer 6, which I hope you're not, it will still work using iframe and such kind of things. So in terms of security, it's not great, but yeah. So if I start this, I need to find my main.
Yeah, just run that one.
Yeah.
We're good. We're good.
OK. And I go there, and hopefully I will have a web view. No. Yeah, because localhost, that doesn't work.
OK.
And what you see here is the events flowing. So let me retry more slowly and reload the events, because that's one of the great aspects of event sourcing, is that if I have my log file, I can replay it many times. So it's removing and every event, and so on and so on and so on. So it's exactly the same graph using a web technology. The only issue is that, Kirk, we need to discuss with the guys that did the browsers.
We need to be honest about browsers and visualizing data and stuff like that, and eventing into them.
Yeah, we spent the last 20 years to optimize Java. It seems that they missed the memo. If you try to send all the events we have to the browser here, something very cool happen.
You'll kill the browser.
Yes, because it just
doesn't work.
It doesn't
work.
Handle the load very well, even for such kind of things where, seriously, there is nothing on my page, right? Just a graph. So, and it doesn't work. So what we had to do, initially I was thinking, yes, that's what's going to be my new aggregators. And that's pretty cool. You just listen for the same events and rebuild the same thing. That doesn't work. You need to have a server side that is actually here.
It's just so much easier to do this in JavaFX, where the things run at the speed of Java.
Yes.
Meaning that there's still a play for desktop applications here. There's just so many things that we can do in a desktop app that we still cannot do in a browser.
So typically here, it's accumulate all the events as we were doing before. So method body, if it's an instance of save point, save it, and so on. And every 100 milliseconds, it's going to send that to the browser. This page is very simple. If you get a page a little bit more complicated, you have to increase, and so painting takes time, you have to increase that. Half a second is generally a good mix, but yeah, you can't send more events than this. It just doesn't, it just blow up before that. It's actually very interesting that even in 2018, regardless of browser you use, Firefox, Chrome, or Safari, they're all going that way. I need to try with links.
You get the same thing. You get the same thing. Like if you look at Sean and when he does his orbital stuff, I mean, they could only do that in FX.
Yeah.
Not in a browser. I mean, the browser gives you an easier deployment model, but you're going to take a complexity hit dealing with the performance issues.
OK, so what have we learned there?
What have I learned there? Well, first off, I have to go back to one of the first event-sourced applications that I worked on. It was like a long time ago. I don't want to tell you how long ago. It was, well, Corba was still actually being developed.
That was good old time.
And we decided not to use it because, for the same reasons that they took it out of the JDK, actually. So, what we found is that at that time, that was probably one of the largest distributed applications that was written on the planet in terms of the amount of data that we're processing and the server farm that we had. And really, what allowed us to scale out and scale up was event sourcing. Now, we didn't have all of the fancy tools and names for things that we have now. That space has gotten a lot better. But I still today find that event sourcing is really the best way to, one, build an application, not a monolithic application, but an application that actually can be decoupled and will scale up, scale out very nicely as your problem gets bigger and bigger. And it also offers you some interesting decoupling so that you can segregate the problems, so that actually you actually end up with fewer performance problems if you do proper segregation of delegation of responsibilities between each of the components in the system. And so it just becomes overall just a much better model. And just having something that actually supports this thing like right out of the box and suggests that, this is that you should follow these design patterns, or your code should sort of follow this code this way, work this way, be written this way, I should say, is just very nice. The integration from our perspective was just very simple, just because we went down the event sourcing route right from the beginning. Yeah.
So, yeah, one other thing to understand is Vertx can be used for event sourcing. It can be used for many, many things. And one of the key takeaway here is that there is no better person than you to understand what you want to do and how you want to shape up your system. And with Vertx, we give you all the freedom to do that. You can do it for event sourcing with the event bus. You can use it for regular HTTP microservices. You can build data streaming system, API gateway, IoT gateways, and stuff like that. We provide a very big ecosystem. And if you are more Japanese style or I don't know, modern style, or if you like Kirk, this British manner where the Wi-Fi doesn't cross the wall, well, you can do that. So
it's to keep the French out.
If you want to go further, there is a book here. So nobody helped me, but I have 4 books. So I will offer one to Kirk because something you don't know. He doesn't want to tell it because it's his birthday today.
Thank you.
So I have 3 more ones. There is stickers here. There is plenty of other sessions about Vertx. Don't miss Paolo's session about JavaScript, because Vertx, you can also use it with JavaScript and on GraalVM, and it has interesting insight about using GraalVM. There is also a session about pure reactive tomorrow. And the last session from Burr tell you how you take Vertx and we put it on Kubernetes, and why having a single thread makes everything much better on such kind of things.
I would say that the fastest applications on the planet are today still single-threaded.
Yep. Thank you very much.
Okay, thank you.
If you want the material, there it is. If you have questions,